Find the slope-intercept form of the equation of the line and then graph it. The original information we are given is that the slope of the line is -1 and the y-intercept is 0, 5. We weren't specifically told that that's the y-intercept, but if you think about where 0, 5 is, it is on the y-axis, therefore it is a y-intercept. Because we are given both the slope and the y-intercept, we can write the equation in y equals mx plus b form, which is slope-intercept form. Slope is -1, y-intercept was at 5. So that gives us y equals -x plus 5. As far as graphing goes, we plot our y-intercept at 5. Down 1 over 1 is a slope of -1. Connect those two dots, and you've got your graph. Find the equation of the line with slope -3 passing through the point -3, 9. Now this point is not on the y-axis. It's right here. Now we can still do our graph. If we plot the point -3, 9, and then we count down 3 over 1 from that location, that gives us another point to connect and we get our graph. Graphing lines are very easy. You just need 2 points, and the rest of them will cover all the other ordered pairs. As far as writing the equation, that's not so easy. What we'll do is we'll use what's called a point slope formula. That's written here in purple. The point given has an x and a y coordinate. The slope, it was given, so we plug everything we can into this formula. Y minus our y coordinate of 9 equals our slope, which is -3, times x minus the x coordinate of our point, that's -3. 2 negatives back to back, that gives us a +3 in the parentheses. Y minus 9 equals -3 times x plus 3. Distributing -3, that gives us y minus 9 equals -3x minus 9. Solving for y, because slope-intercept form is y equals mx plus b, we add 9 to both sides. That leaves us with y equals -3x. Notice the constant out here is an unwritten 0, and if you go back to your graph, if you start at the point -3, 9 and you consistently count down 3 over 1, you hit the origin. Passing through the origin, that's a y-intercept of 0, so that's why there's an unwritten 0. Find the slope-intercept form of the equation of the line that has a slope of 1/2 and goes through the point 8, 4. This point is not on the y-axis. That's over here in quadrant 1. Y minus 4 equals 1/2 times x minus 8. Multiplying by half, we get 1/2 x minus 4. Solving for y, we add 4 to both sides. We're left with y equals 1/2 x plus 0. It's totally fine to write plus 0. That will tell you where your y-intercept is located. Our graph will pass through the origin and the point given, 8, 4. To double check that your slope is half, if you repeatedly move up 1 over 2, you will notice that you keep landing on the line and eventually you reach 8, 4. This problem, we're given 2 points to start with. 3, -1, -5, 2. Let's plot them both. 3, -1 is here. -5, 2 is here. Go ahead and connect those 2 dots and you've got the graph of your line. Again, that's not always the hard part. The hard part is coming up with the equation of it. Also, we don't always get a clear cut through the y-axis. So that's why it's important to verify using point slope formula. Neither of these points are on the y-axis, so we don't want to really just risk it and take a guess. It looks like it could be 0. Turns out it's not. First, let's get our slope, and you can either do that by counting the grid from dot to dot. We would go down 3 over 8 for a slope of negative 3/8, or you can use your slope formula. y2 minus y1, 2 minus negative 1, that's 3, over the difference in your x's subtracted in the same direction, negative 5 minus 3, that's negative 8. So we get a negative 3/8 slope. Now, getting the rest of it, we take the slope we just calculated, either by formula or by counting the grid, and then you pick either one of these 2 points to be your x1, y1 substitution. You can pick either one because your line goes through both. I just randomly chose the first point. Y minus negative 1 equals negative 3/8 times x minus 3. Distributing negative 3/8, that's negative 3/8 x plus 9/8. On the left side of the equation, the two negatives back to back is a plus sign. Solving for y, I subtract 1. On the right side, I subtract 1. That's still 1, 8 over 8. It's a weird looking 1, but I did it so I'd have a matching denominator. 9/8 minus 8/8 is 1/8, leaving us with an equation in slope-intercept form of y equals negative 3/8 x plus 1/8. Notice our x term contains the slope. That's a good sign. Those have to be the same if we've done it right. And then this tells us that our line crosses the y-axis at 1/8, just barely above the origin. Find the slope-intercept form of the equation of the line that goes through the points 3, 2, negative 5, 2. I'm going to plot both of those. Negative 5, 2 is over here in quadrant 2. 3, 2 is in quadrant 1, so I've plotted both. When I connect them, I see that I've got a horizontal line. All horizontal lines have a slope of 0. This one cuts through the y-axis at 0, 2, so that's our y-intercept. Writing our equation in y equals mx plus b form, y equals mx plus b. Because our slope is 0, we don't have to write the x term. Y equals 2. If you take any point on this horizontal line, its y-coordinate will be 2. For the other special case, we have points that when plotted, 5, negative 3, that's in quadrant 4, 5, 1, plot that, that's quadrant 1, so we have quadrant 4, quadrant 1. These dots are vertically oriented from one another, so let's connect them with a line. This vertical line represents our graph. All vertical lines have undefined slope. This one does not cross the y-axis, so none. Every point on this vertical line must have an x-coordinate of 5, and so that's our equation.